Hey there, today I'm going to be talking about trigonometric ratios and right-angled triangles. The reason I'm making this video is so everyone out there could learn about trigonometric ratios. I once struggled on this topic, and I wish by making this video you will have all your questions answered. I will begin the video with identifying right-angled triangles and identifying acute angles. And then, by the end of the video, I assure you, you will have learned everything you need to know about trigonometric ratios. Thank you. Hello there. Today, we will be learning about trigonometric ratios. Trigonometric ratios allow us to solve unknown lengths in right-angled triangles. We can only use these ratios if at least the measurement of one acute angle is known in that triangle. Before we learn how to use these trigonometric ratios, we must first look at what right-angled triangles are, and also we must look at what acute angles are. Let's start off with the basics. When a triangle possesses a 90-degree angle, as shown in this picture here, then it is known as a right-angled triangle. When a triangle does not possess a 90-degree angle, then it is not a right-angled triangle. Here we have an example of a right-angled triangle. Notice that when you see this symbol, this indicates that it is a 90-degree angle, which also means it is a right-angled triangle. Now that we have learned to identify right-angled triangles, we will learn how to identify acute angles. Acute angles are any angles that are less than 90 degrees. This includes the angles 0 to 89 degrees. The way we measure angles is using a protractor. In the following diagram, we see three different angles, all of which are acute. The first angle is 60, the second 30, and the third 10th. Now that you have learned to identify acute angles, we will move on to trigonometric ratios. Before moving on, I advise you to watch the first part of this video, which includes identifying both right-angled triangles and acute angles to help you understand trigonometric ratios. In trigonometry, we have three basic ratios: the sine ratio, the cos ratio, and the tan ratio. The following ratios can be easily remembered by the following acronym, as seen in the diagram. In the diagram, we have the acronym SOHCAHTOA. Now let's examine the ratios in depth. Sine ratio. Sine equals opposite over hypotenuse. This means you take the opposite value and divide it with the hypotenuse value according to where your angle is. Cos. Cos equals adjacent over hypotenuse. This means you take your adjacent value and divide it with the hypotenuse value according to where your angle is. Tan. This means you take your opposite value, divide it with the adjacent value according to where your angle is. These three ratios can be easily remembered, as well as their function, using the following acronym, SOHCAHTOA. So, opposite over hypotenuse. Ka, adjacent over hypotenuse, and toa, opposite over adjacent. Remember, when using right-angled triangles and trying to solve them using trigonometric ratios, always write out SOHCAHTOA. So far, we have learned how to identify right-angled triangles. We have also learned how to identify acute angles. We also further explored trigonometric ratios, and we looked at their functions. Now we will look at how you label right-angled triangles. Now let's have a look at the top triangle. In the top triangle, we observe theta located on the top right-hand side of your screen. Remember, when labeling, you must label corresponding to theta. Here, of course, we have theta, and we have labeled it accordingly. Opposite is here, adjacent is here, and our hypotenuse is here. The hypotenuse is the longest side in a right-angled triangle. It will always stay the same. Make sure you have a close look at this triangle here. Keep in mind where theta is located. Now let's have a look at the bottom triangle. If you remember, theta was located up here in our top triangle. Now theta has changed. If you haven't already noticed, both our adjacent and opposite sides have changed as well. Remember, when theta changes, so does our opposite and adjacent side changes. Here we have theta on the bottom left-hand side of your screen. If you've noticed, the opposite side has changed accordingly to where theta is located. Our adjacent is beside it, and our hypotenuse is still the same. As you remember, as I said earlier, the hypotenuse side is always the same. It is the longest side in a right angle triangle. Always remember that adjacent simply means beside. So here we have theta, and we have our adjacent side, or beside side, and we have our opposite. Now let's have a look at both triangles. As I said earlier, our thetas are different, so will our opposite and adjacent sides be different. Now that we have looked at how to label right angle triangles, we will learn on how to solve and use trigonometric ratios accordingly. The next step is determining which trigonometric ratio to use and why we're using it. Below, we will look at a few examples to help you understand which ratio to use. In this diagram, we observe theta, but this time it is 70 degrees.